Welcome to another video on my new channel here on YouTube. My name is Jonas and I am a Swedish math teacher. And today we've got a problem here about a right triangle and three semicircles. The area of the red semicircle is 9x, of the yellow semicircle is 16x, and the length of this side here in the triangle is x. So, please pause the video and try to find x. So, I hope that you solved it. The first thing I'm gonna do is to throw this picture away for a bit and show you another one instead. And I think that you recognize this picture as the picture usually shown as for the Pythagorean theorem, this one. And if we have the sides of the little square equals a, and b is the sides of the middle square, and c is the sides of the large square, then a squared is the area for the little square here. And b squared is the area for the middle one, and c squared is the area for the large square. So, the Pythagorean theorem tells us that if we in a right triangle take this little square and add the middle one, you got the area of the large square. Fine. But does it help us? Yes, it can do. Because look at this picture here. This picture tells me the difference between the picture here and the picture in our example here in the question. It is the difference between a semicircle and a square. And I know that the ratio between a square and a semicircle remains the same regardless of the size if they share a side. So, the ratio between the whole area of the square and the area of the semicircle is the same for big squares and for small squares. And for the squares in the middle, of course. So, you can say that the whole square has an area of A, the middle one, the semicircle has the area of B, and then I can say that A divided by B equals K. And K is a number, and it is the same number if I drew the picture big or small. And this can be rewritten as I can take the area of the square and divide it by k. If you divide both sides of the equation by k, the k got in the denominator down here. And if you multiply both sides by b, b turns to the right side here. So, the area of the square divided by k is the area of a semicircle. And then we can use this equation here and divide all of these areas, a squared, b squared, and c squared, with that number k. And it gets us another equation right here. The area of the square, when we divide it by k, it becomes the area of a semicircle. The area of the middle one becomes a semicircle too, and the area of the big square also becomes a semicircle. So the new equation is this one. You take the small semicircle's area, add it with the middle one, and you got the area of the big semicircle. So now we can solve our problem, I think. We have our new equation right here, and if we take the little area 9x here and add it with the area for the yellow one 16x, then we have the area for the blue circle. And the area of the blue circle, we know that the area of a whole circle equals pi times radius squared. And for a semicircle, it is a equals pi times r squared divided by 2. And r is our radius in the circle. The radius in our circle is x divided by 2. So if we take pi and times the x divided by 2, the radius and squared, and divided by 2, then we got the area of the blue semicircle. So the equation is this: 9x plus 16x equals pi times x divided by 2 squared and divided by 2 again. On the left we have 25 times x, and on the right we have the same number. But I want to multiply both sides by 2, so this little guy goes away. And then we don't have 25 anymore, then we have 50 on the left side. And on the right we have pi and x divided by 2 and squared. So you can put the exponent to the x and to the 2 right here, and then you got this. And then we can multiply both sides by 4 and then get 200x equals pi times x squared. And to solve this equation, we put all of the terms on one side, so we can subtract by 200x, so we got 0. So pi times x squared minus 200x. And then we factorize x out, so we've got x and a parenthesis with pi times x minus 200. And now we can solve the equation. And this is the zero product property that tells me that to become 0, either this x in front needs to be 0, so this is 0, or the whole parenthesis, the other factor, are being 0. So one of them equals 0. And for this one to be 0, you can take it out and write it as an own equation and solve for x. So add 200 at both sides. Then you got pi times x equals 200, and divide by pi on both sides, and then x equals 200 divided by pi. And of course x can't be 0, because then the picture don't exist if all the lengths are 0. So this one here is not okay, it's not valid. But the answer for x is this one here, 200 divided by pi. Was it the same as you got? If you do like this video, please give it a thumbs up, and yeah, see you in the next one maybe. Bye bye, see you.